little completing the square. I already have one prep for you guys. If you know, it's up to you guys what you want to do. I'll let you, if you want to copy it, fine. If not, you want to just watch, that's fine too. No big deal. You will have one of these on tomorrow's quiz somehow where it's not going to be in your usual circle form that you like. Just a reminder of the circle equation that I need to get it into: x minus h squared plus y minus k squared equals r squared. Which variables are we concerned about? Okay, h and k. What does h and k tell me? Those are the x and the y coordinates of the center. And the other part is r value, which would be my radius. All right, everyone ready? So we're going to complete the square to make it go from my original to the circle equation. First step, I'll open it up to you guys. First step, Hugh, move the 3 to the other side, and I'll do the next step at the same time. Group your x's and y's together. Okay, so x squared minus 2x plus y squared plus 6y. Move the 3 over by subtracting it. It becomes negative 3. Next step, complete the square on your x's and then on your y's. So let's start with the x's, everyone. How do you determine what c value I need to add to the x's? What's the process of determining the new c value? Half your b value. What's half my b value? Negative 1. Square it. Okay, so that's what I'm going to add to the x's. Let's do the same thing now for your y's. Half your b value is 3. Square it. Okay, so I'm going to add 9 now. Here's the part I always, every year, we forget. It's tipping to the left. Why is it tipping to the left right now? Because I added 10 to the left, but did not add 10 to the right. One more step. Go back to your x's. So I don't have to try to factor that. What should go inside? What was half your b value again? Sign goes with it. What was half your b value? Minus 1 squared. Plus, do the same thing. What was half your b value on the y's? Plus 3, all squared. And over here I have 7. Anything you want to ask so far before we find the center and the radius? Okay, so what would be, let's first start with the center. What would be the center of this circle? 1, negative 3. H. And if I'm going to get a positive 3, I must have plugged in negative 3. And you can, we'll just leave it. I don't need a decimal here. The radius length, if there's a 7 there, it's not 7. Remember, what is this value right here in the equation? That's what? Radius squared. So if you want to solve for the actual radius, do what on both sides? So that it's the square root of 7. That's the length of the radius, is the square root of 7. All right, so there's a little completing the square for you. Sure, we'll go right ahead.
How does it go to 1, negative 3, 1, 3, negative 1?
Okay, remember the equation. X minus h, right? So x minus h. So y, oh, how did I get a positive there? That k value must have been negative. Okay? Amy? Yes. Oh, what do you mean, from the equation to the center and vice versa? Yes, yes. That's another way of remembering it too. Unless it's, we talked to, unless you just see an x squared, nothing with it. What's the coordinate there? 0. Okay. Anybody else? Topics? Whatever you guys got, I have no problems going over today. As silly as it may sound coming out of your mouth, it does not matter today. Can come from the packet, can come from up here. What's up, Maggie? Okay, everybody, let's hit up number 26. That's not the one I want. I feel like somebody messed with my projector because this is not how it usually looks. I got it. 26, yes, the old pulley. Go over it all here, Maggie, or you're going to ask me a specific? Okay. Yep. Okay, based on a circle fact, right away we should be able to add something to this diagram. Forget about finding the distance from A to D. Anybody, what can I add right away up here? 2 right angles, specifically at B and C. Radius drawn to a point of tangent C is perpendicular. It's happening twice. Now, if I draw in the distance from A to C right now, is that a rectangle? No, because these are not right angles down here. I have no idea what type of angles they are. But I can make it into a rectangle. Everyone, oh, I better label some. AB is 7, BC is 13, and CD is 4. So here's how I'm going to make the rectangle. I'm going to take the shorter radius, which is what? 4, and I'm going to draw a line in to my best ability that's going to be parallel to the line that's labeled as 13. And that will make a rectangle. Everyone see the rectangle on the top. What's the side opposite 13? 13. Side opposite 4 is 4. What's the remaining piece of the radii then? 3. And remember what we said. It's a I made a rectangle here. So what do I know about all the angles inside this rectangle? Okay, they're all right angles. So that's a right angle, which means how about the one next to it? Okay, I asked you that because now I formed a right triangle. What is AD acting as in that right triangle? Is that the hypotenuse or one of the legs? Okay, so I can go 3 squared plus 13 squared equals that length squared, C squared. And then now it's just crunching some numbers on the calc. And then whatever that ends up being to the nearest tenth for the rounding. We okay, Maggie? Yeah. Okay, so again, start with, if this is on there tomorrow, start with the shorter radii, draw a rectangle across, and then do your Pythag with the right triangle on the bottom. All right, good question. Cam, then Mike. Okay. 3 and 4 from the packet? Yeah. Okay. Still could be, certainly could be part of a big circle question, though. All right, let's start with 3. Arc QS is 110. Find the measure of SQR. All right, here's one of those strange angles. It's not inside, it's not outside, right? Why is it not inscribed? Because QR is not a chord. It's a tangent. But I do have a rule for you. I do have a rule. An angle formed by a chord and a tangent. Let's see if I put it on that page 50 to 51 there. Let's see, chord and a tangent. Did I put it? Central angle, inscribed. Right angle, supplementary. Doesn't look, okay, good. So we're going over it now. Anybody remember how to find the angle formed by a chord and a tangent? It's 1/2 times the arc that it's in between or intercepts. What's the arc measure it's in between? 110. So I'm going to take half of 110 or 55. All right. All right, let's go to the other part now. QTS is 240, same deal now. Everyone see this angle now formed by a chord and a tangent still? So now I'm going to take half of 240. Again, guys, read tomorrow, right? Read. Make sure you're answering for the arc or the angle that's asked, not the one that's convenient. All right, read it carefully tomorrow. Mike, go ahead.
I was just wondering what problems you need the quadratic formula for.
Sure. I don't know if I have any on the review, but I'll show you what I mean. Can you guys take a look at I don't know. Let's just take a look at, so we're not going to waste time. Let's just take a look at 17. Okay, here you go, 17. You got two secants. The external segment of the first secant segment is 8, and its internal segment is 1. So 1, find the length of the second secant segment if its external segment is 6. So it's asking me what is the length of the whole second secant there. And just let me solve this one, Mike, and then I'll answer your question at the end here, because it's not going to apply here. All right, what are we trying to remember for lengths of secants and tangents? Okay, ready? Give me a whole secant. 9, yep. Don't do 1 times 8. That 1 has nothing to do with in the formula anyway. 9 times its external part. 8. Other whole secant.
X plus 6. Or no, just X.
Okay, let me go. Let me put X there. Instead of calling the whole secant X, what would happen if you called the internal part X? So go ahead now. Now it's X plus 6 times external part 6. If you do it this way, I just warn you, what are you solving for when you end up with X? Internal part. Just watch out for that. That's not my final answer on this one. If I call the internal part X, I'm going to have to add it to 6 at the end. So 72 equals 6x plus 36. And let me stop here and answer Mike's question. Mike, you may set something up tomorrow, whole times external equals whole times external, where you get like x squared minus 2x minus 24 equals 0 after you move everything over, and you got to factor it or use quadratic formula. So something like whole times external tomorrow, yeah, you may have to factor or use quadratic formula. Avoid what? You get an x squared, you get an x squared. Can't avoid that. All right. All right, so you end up with what here? 6x. Thank you. 6x equals, we got 36. X equals 6, but again, that's the internal part, so the whole thing's going to be 12. And if you called the whole thing X at the beginning, you would have gotten 12 as well. All right. I have no idea what this is. Questions, comments? Yes, Amy. Go ahead, I'm ready. Floater angle. All right, should we try a big circle question then? Okay, you may have already done it on homework last night because I assigned the 2 that I have on the review. Actually, no. Did you guys get 20 or no? All right, let's go 20. We got to hold on. And yep, and that answers Amy's question too. All right, here we go. Big circle question coming back tomorrow. Again, the key to these big circle ones, find all the arcs if you can first. Don't look at everything you got to find. It may get overwhelming. Ooh, a lot of ratios, huh? What am I throwing on BC? 5x. How about CA? 4x, AN, X, and NB. 2x. All right, like, can we find the arcs before we get started? What are you doing with all 4 of those? Okay, so I got, let's see, 12 of them. 12x equals, be careful, don't put 180. 360. X equals 30, all right. So go back now. Let's figure out all the arcs now. BC, 150. AC, yeah. NA and NB. Okay, we all ready to roll now. We got all the arcs. We should be pretty powerful now. All right. All right, part A is already solved. BC, 150, right? All right, let's figure out what type of angles we're dealing with. Angle ABC, part B. ABC is inscribed. We just got to remember, what's the rule for inscribed? Half the arc. What arc measure is it drawn to? Buck 20. ABC, 60 degrees. Angle NMC. Where is it? Outside, right? Is that adding or subtracting the arcs if it were outside? Yep, subtracting, half, right? Okay, be careful. Identify the arcs now. Hey, mate, I have a slew of colored pencils over there that you certainly can use tomorrow. Ready? Here's the angle. What's the major arc that's in between it? Not 120. Everyone see it's 150 from N to A to C. 150 is the major arc. And how about its minor arc? 60. Half a 90, also known as 45. And I've been doing a terrible job here. I should be labeling every angle I find because I may need it later on. All right, now to your topic here, Amy, angle NDA. Everyone locate NDA. Central, no. Inscribed, no. It's a floater angle, so half of, what do I do with those arcs? Okay, so NDA belongs to what angle, what arc measure? NDA, its arc measure is 30. And I add its vertical angles arc now. So here's NDA, here's its vertical angle. That arc measure is $1.50. Half of 180. Oh, look at that. That's a right angle. And here's usually this last, go ahead, Hugh. Sure. Usually this last one, people are on a roll and then the brakes pump on. And this last one, MND. Don't automatically throw a 90 out there. Is ND a radius? Okay, so it's not radius drawn to a point of tangency. All right, MND. Cam just asked this question. Some of it's on the outside, some of it's on the inside. How's it formed by what's NC? Chord NA, tangent. What was the rule we just went over a couple minutes ago? Chord into tangent? Half its arc, right? So angle MND. Now that, okay, you know it's half its arc, but the tougher part is, what is its arc? Everything from N to B to C. Everyone see that arc in between? So 60 and 150, 210. Hey, before I move on, are we okay while I'm taking half of 210? See the arc right here, this arc in between. Right there. And that'll be 105 degrees. Yes, Justin, hello.
Can I do find the angle NCM and then do
Okay,
180 minus 45 minus?
Yeah, sure. So you want to, more colors here. Sorry, everybody. Blue. So Justin wants to take this triangle here. He already knows that's 45. And then you want to do this angle, which is inscribed. Yep. Take half of the arc and then find that angle, which will be minus 180. Yeah. I don't care if you use the circle fact. That's fine. Yep. Anything else going? Topic-wise. Questions? Anything here? Last opportunity, because I'll just give you the quiz as you walk in tomorrow. Yep, that's, well, hold on. Well, let me just show you real quick, Cam. We already, I'll do a chord one in the next, but that's secant, whole times external. Okay, good there. All right, let's do a chord one. Can you guys go to in your packet? Actually, I have it. I did it first period. Which chord one did I do? Big circle. No. There we go. Question 10 and 11. First thing, just look at the diagram. Tell me a theorem I should apply right now. Even I don't care about the lengths at this moment. Diameter. I got a diameter or a radius perpendicular to a chord. What's happening? Bisects. What's getting bisected? AB, the chord. Yep. So these two pieces are equal based on that theorem. So CE is 16. AB is 16. So each piece here, 8. And find the length of ED. Yes, Will. Well, hold on. Let me ask you a couple, so everyone knows where we're going with this. What's AB in the circle? And what is CD? Diameter, also a chord. And they intersect. We have a theorem. If two chords intersect, their segments, the product, when I multiply them, their segments are equal. Name two segments of one chord up there. 8 and 8. So I know the product, when I multiply them, of 8 and 8 is going to be the same as, what about the other chord that it intersects? 16 and X. Yep. Their segments are equal to each other. Correct. Yes, correct. On the same chord. Yep. And then you're on your way. Questions? I'm going to add one other thing in here in a minute, but anything before I add in a little piece here? Because I know I do want you to be as successful as possible tomorrow, because I know some of you guys want it and need it. Okay, I know we went over these proofs yesterday, but I just want to add something in. That triangle proof we went over, 25. You don't have to write any of this down. I just want to see. It's actually a little bit of a review. Absolute value. Remember those from your algebra days? I was teaching that today. What step did we prove the triangle's congruent? 5? Okay, we proved the triangle's congruent in step 5 by side, 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 right? Okay, let's just say, though, I didn't want the triangles congruent. Instead, I wanted angle BAD congruent to DAC. You just proved the triangle's congruent by side, side, side. Why would those two angles now be congruent? Nothing to do with circles. You just proved the triangle's congruent by side, side, side. What would be your next step or reason why those two angles would be congruent? CPCTC, okay? Just in case I ask that tomorrow, we haven't used CPCTC in a while. Okay, next, go to the next proof we did with the similar triangles. Because the proof tomorrow could be proving triangles congruent, or it could be proving triangles similar with a couple extra parts to it, and I want you to be ready. Well, all right, whatever step we proved them similar. Six. Ready? Okay, what if I wanted the following? Instead of this similar triangle statement, what about proving AD over DB equals AC over DC? What if that was my proof statement? That those sides are in proportion. You proved them similar. Now this is true because of, ooh, not there, no, not there yet. Why are corresponding sides in similar triangles proportional? C, SSTP, yep. And one more step for review. What if I wanted this? AD times DC equals DB times AC. Going this way, cross multiplying. Why are those congruent? Product of the means equal product of the extremes. Yep. And I'm sure there's a reason why I'm taking 5 minutes to just review this. Okay. And if you have to set this up yourself, make sure AD and DC are diagonal, not on top of each other or across. Okay, because that's the only way I'm going to cross multiply them. Anything else from you guys here? We still got plenty of time. Anything else from you guys? Go ahead. Okay, I'll end it there then, and you guys can keep going in your packet. Just do me a favor so you don't get stressed out tonight. You don't have to worry at all about question 22. Okay, finding the arc measure. I will be here.